No.
No? Can you hear me? Okay, better. So, first of all, a disclaimer. It will be possibly an interactive demo. So I will be happy if I see someone running the commands, and you will also have a nice Homer t-shirt if you do it.
But you should approve it.
Yeah. So a couple of questions. Yeah. It's loading. Great. I don't know why it's not presenting. Okay. We start good. Okay. It's not important. So just some questions. How many of you knows Homer already? That's good. How many of you use Homer in production? All right, really nice. And this is the. And now the hard question. How many of you are using Homer 7? You deserve a t-shirt. Okay, so that's why we are here. To understand why, even if we launched Homer 7 almost more than 1 year ago, the rate of utilization is still too low for what we would like. And does someone want to answer why you are not using Homer 7? Okay, this I'm asking because one of the more frequent remarks that we get is that it's too complicated to install and there is no installer. Okay, let's see how we can go.
And also because Homer 5 works, yeah?
Yeah, Homer 5 works, but I have yeah, sure, I forgot. I have bad news. Homer 5 is dead. Yeah, there will be no more update and no more new feature for sure.
No, patch
and
some patches.
Some patches, so mainly the security related one, but that's it.
Yeah, but main focus will be exactly on Homer 7. So
and you have a lot of good reason to switch to.
Yeah.
So let's see. First of all, we have a live channel on Gitter. If you want to ask some questions live to Lorenzo, who is back home and is following the presentation. So if you have something that you want to ask now or later, you can use this channel. So let's have a quick look on Homer 7. So Homer 7 has been a major rework of the Homer platform. So first of all, we have on the you know the big blocks of Homer. So basically, we have a side which is injecting, producing data, and sending it to a capture server which extracts the packet, the statistics, and on the other side we have the databases where we store the traces, the data, and separate databases for statistics. And this has been the major news, is the major news with regard to Homer 5. In Homer 5, we had internal statistics generated using MySQL, and this was using ADB, generally speaking, and this was for sure not a good choice. So it has been decided to let this job to who is best doing it. So a time series database or a more modern database like Prometheus, InfluxDB, Elasticsearch. These are the three ones that we targeted because they are the most used around, basically. So basically, how the app flow today is not so different from the app flow in the past, I say, but we have some major news. First of all, we have our to-capture server. In the past, traditionally, we used Kamailio as a capture server, and this reached the limit of what we could do with Kamailio, which is not close to this, for this. So we have two new capture server, and Amplify server, which is written in Go, is more thought for legacy protocol, SIP, RTCP, and well, what we call legacy RTC protocols. And an EPOP, another server, another capture server written in Node.js, which is more thought for the WebRTC stuff. So for example, is where Janus events, MediaSoup events, or Jitsi events are parsed and treated.
And also for development, if you would like to develop a new protocol, of course it's in Amplify server, it will be probably take a little bit of time, but in Node.js, JavaScript, you can just add a new protocol, test it, how it works, and after we can exactly implement it in Amplify server. And what I would like to say about Amplify server, Kamailio is a great product. But unfortunately, from insertion in databases, SQL database, it doesn't support bulking process. Test. Okay. It doesn't support bulk process, and exactly in Amplify server we implemented bulk, and we did some tests just for fun on let's say normal hardware without any specific acceleration. It shows 150,000 message per second what has been inserted into Postgres database. 150,000, yeah. So it was just amazing numbers. We also tweet about it. In this case, if you would like to build a huge cluster, big cluster, we recommend to use Amplify server in this case. Yeah. Okay, sorry.
Oh, thank you. The second step of the flow is that the packets received by the server are splitted by app type. Do you know what app is? Who knows what app is? Fred?
You get also two shifts.
So app is the Omer encapsulation protocol, is the protocol that we use to encapsulate from the agent the data that we want to send. We'll see later in the workshop some example of this protocol. But yeah, this protocol carry also the type of data that is being pushed. For example, if it's a zip packet, we have a protocol type 1. If it's a log, we have a protocol type 100. RTCP is a protocol type 5. And of course, you can also define your own protocol, as Alexandr said, and have it parsed by a POP, inserted in his own table, etc.
Just for additional information about HEP, HEP was developed so that you can make own chunk. Yeah? In this chunk, you can implement it any types of what you want. Yeah? So it will be very easy to implement its own protocol dissectors, which can be sent to an Amplify server, and automatically it will be created new table and it will be inserted. Yeah? So it will be very easy to develop some additional stuff like WebRTC for Jitsi, for Janus, MediaSoup, and etc. And especially, for example, we just implemented in Capt agent ISAP, M2A, M3A, and it's we automatically just sent like JSON encapsulation, and it's set to Amplify server, received by Amplify server and set to Postgres database, and you can exactly do same like before, making correlation between C protocol and ISAP protocol. So.
Okay. So once the packets are classified, they will be on one side inserted by bulk on the DB, or the metrics will be extracted and pushed or pulled to your time series database according to what you choose. So currently we have on the right the database and time series options that we offer. The database is Postgres SQL. In Omer 7, we removed the support for MySQL for several reasons. One, for the performance reason that Alexandr highlighted. Partitioning, better support for JSON, since now Omer is natively handling JSON. So JSON, Postgres was a better choice for this. We have Grafana Loki. Do you know anyone know what Grafana Loki is?
Okay.
Yeah, well, so Grafana Loki is basically a log aggregator which is included in, or basically yeah, included in Grafana, is tightly bound to Grafana. And there's a labeling system like the Prometheus one. So in a nutshell, you can have metrics and statistics sent to Grafana with the same label. So offer, and it has a query language for which you can query for logs for specific strings, etc.
Text,
yeah.
Tagging and so on. Yeah.
And you see how we use it inside Omer. We have Elasticsearch that can be used both for sending the packet and storing the packet, both for statistics, and we have InfluxDB and Prometheus. And on the far right, we have the Omer app and the Omer API, which has changed. This is another big change with regard to Omer 5, where we had Apache, PHP, and a lot of stuff. Now it's Node.js. The API and app are a Node.js application that you can simply install with a npm install, or as we see, use a pre-done Docker container. So, as I was saying, one of the remarks that we got is that, all of this is complicated to install. It's complicated. Sometimes people don't understand that you don't need all of this choice at the same time. So that's why we choose to...
No, script already exists. Exactly, it has been released a week ago, so it's in our repository.
But there is another problem with script. Are you pretending that the Kamailio, for example, script installed for you MySQL and all the stuff? No, it doesn't do it because it's not its role. So the same concept should apply.
Yeah, but okay, but users are lazy, so normally they they want to just run one command and it will be automatically up and running. Yeah.
Okay, this is my personally, I don't like install scripts. It's so 80s. Sorry.
But it was so many requests, but we have to implement it.
And you end up with a messed up system. Do it twice, and you will have a messed up system. Mainly if you are installing or even some of these components. They have different dependencies, different updates. One fix on or one update on one of these components could break potentially others. I always prefer to separate things. That's why
packages is the best way.
Packages also, but yeah, okay. So that's why we baked different flavors of Omer with using Docker and Docker Compose. Another question: how many of you use Docker Compose and knows what?
Even Docker. Who knows about Docker?
And how many use Docker in production?
Okay, brave.
Okay, so just my little story. I've always used Omer only on Docker, even the 5, always. And I had never had one single problem.
Yeah, because it's always a question, why Docker? We don't want virtualization, yeah? And I tried to explain what Docker is not a real virtual machine, yeah? So it's, okay, it's container which code will be executed on the same level, yeah, just different libraries and that's it. So overhead, it's just not so big, yeah? What should we care about? This is not VMware or whatever for Oracle. So I think it's Docker. It's a nice application which you have to use also in production. And many companies, huge companies, they use Docker in production without any problem.
Yeah, well, this is another topic subject, quite big. So as I was saying, we bake some flavors of Omer. So we have a based on amplifier server or APOP server with Prometheus or InfluxDB or Elastic. We have a version with Elastic headless, meaning that we just install the capture part. We don't have it for some use case where they don't need a trace, they don't need to store all the trace, but they need more stats and big data. So we use Amplify server and we just send everything to Elasticsearch, and then you can do whatever you want with. So for this workshop, we've prepared a special configuration, a special compose, just to show you what you can do. In this compose, we will have, of course, our Amplify server, Postgres, InfluxDB, and Grafana Loki. And on the UI side, on the UI layer, we'll have the Homer app and API. I decided to install also Chronograph, which is the user interface for InfluxDB, and Grafana, just to show you that it's really easy to set up two different user interface according to what you prefer, to what you're used for, to what you use to what you use in your company. Probably maybe you already have a Grafana, so it's not needed to install. We'll see. And Caddy, which is a small HTTP proxy that will just proxy our port to the services. So we'll have 3 open ports, 9080, just an arbitrary one, will map to Homer app and API, 9090 to Chronograph, and 3000 straight to Grafana. And we'll have a listening port for our Amplify server, then the port 9060 on which the capture server listens to, which is the same, the standard Homer port. So on this socket, we will listen for app. So now it's the time of the interactive part. If you want, you can run the command that I'm showing you. So for this, to spin up this Homer 7 lab, we need a basic and Linux host with one CPU is more than enough, and 8 GB of RAM, Docker CE, and Docker Compose, the last one. And yeah, you can clone this, the repository, the zip catcher on Homer 7 Docker. With you can just clone the branch for the workshop and change to this directory, Homer 7 Docker, Amplify server, Homer 7 Influx Graph Loki. I'm going to do it. Yeah. Okay. Okay. Everyone copied?
Copied.
Okay. Okay. Did someone launch the command? Okay. While we wait that all the images are pulled and started, let's have a look at the compose file. So as I said, in the compose file, we have the different services that we are shipping. As I said, the first one we find in the compose file is the Caddy proxy HTTP proxy. There's not so much to say. Here we see the public mapping of the ports.
So, for example, if a port is busy with a different application, so we can exactly map external port to internal.
And yeah, this is the Caddy configuration file where you map your exposed port to the internal services. Not so much. We have the container, the service for the database. We are using, as you see, official Docker images. And this is a more important part, is the Amplify server configuration. So Amplify server is our new capture server that is written in Go, so you can launch it as a binary, as a standalone binary. And as a real simple configuration, you can configure via environment variables. And these are the most important parameters, which are the DB address and the DB parameters, generally speaking. And you see, first thing that you can see here, that we are using the Docker Compose service name for the DB. But if you want, this is a place where you can change for an external DB. If you have already deployed a Postgres SQL, or if you have an optimized database, whatever. Here is where you can change. So for example, you could already remove a brick of this composer, starting externalizing the services. Then we have the Prometheus address, meaning the interface to which used for retrieve the data from Prometheus. And this is a really important new parameter of Amplify server. It is DB drop days. So do you remember in Homer 5 we have an external rotation script that needs to be run once a day to prepare the new table. Now this is done internally by Amplify server itself. A little improvement. And we have the deduplication parameter, which used where you have duplicated packets because, for example, you have bonding interfaces and stuff like this, and the URL of the Loki server. And that's it. As you see, it's really, really easy to configure Amplify server. Basically, you can run with a really few parameters, run it, and have it capturing the zip.
It's again, we can say Eugen. Many
yeah,
thanks.
Thank you. Yeah, he's not here.
But he will arrive tomorrow. So
the same. The web app, the same. We have just three parameters for the DB connection to set. Nothing really. And then we have all the part to install the TIC stack. TIC is a telegraph, InfluxDB, chronograph, and capacitor. So we have the telegraph, which is the part, which is the agent taking the data and pushing it to the InfluxDB server. And yeah, again, InfluxDB, which require nothing to be configured. And again, this is a part that you could have external to this compose.
Yeah, in Telegraph, it's also you can use like for internal statistic, like SMNP. So you can get all statistics internally, how many memory it's used, and et cetera, and send also to InfluxDB, just to monitoring server.
Yeah. Nothing here. Yeah, and the Grafana. Here we have the Grafana configuration. We set up. You can have a look. It's the official Grafana image, so you can look of all the parameters that you can configure via the environment variables. But here we just set the username and password. The ability we disable the possibility to create users on the fly. Just a choice. You can have a different choice, and we enable the explore feature, so we can explore the statistics, and we expose the port 3000. Okay, and then finally, this is the Loki server configuration part. There is a configuration file that you can find in the same Docker Compose directory. But basically, is yeah, really simple. I think we could open here to show. It's really simple. You just configure the IP address. In this case, is listening on the loopback interface. And that's it. Okay. And then the last part is the provisioning part, mainly to create the InfluxDB database, the retention policies, and so on. Okay. Now, I will launch here the bundle. Creating the different images. Okay, while we'll wait. So So how do we test a fresh Homer installation? With AppGen. Do you know AppGen? Anyone here know AppGen? T-shirt for you. So AppGen is a bare-bone app packet generator. What does it mean? It means that we use this to simulate what any of the agents, so Kamailio, Asterisk, or your own agent, send to Homer, to the capture server. So basically, it's a Node.js application, and this is how the configuration is done. Basically, once you define the app server target, the target port, and then you fill at least an array of messages which are composed by the famous app header, which I spoke before, and the payload that you want to send, for example, the zip message. I will open one to show you the app header.
So it's normally CP, yeah? CP, HEP CP.
Yeah, we could think to AppGen to kind of CP for
HEP.
For app. For example.
Here it's different scenarios. Yeah, so we have already pre-configured for you. You can send make instance up and send with Heplify. Oh, sorry, Heplify with HepGen logs using this configs.
So this is a more complicated scenario. This is the one that we are going to use, that we are using really. But just to show you, okay. So this first part, RC info, is the app header. Is the I don't know. Can you see it, or is it too dark? Okay, let's see if this way is better.
It's the background.
Better?
Change background to white and
Put a black background.
white background.
Yeah. Change now.
Settings.
Where is it? Better?
It's up, go up. Yeah, it's better. Yeah.
Okay.
And a little bit bigger.
Yeah.
It's better, yeah?
Left.
Okay, so this is how an app header looks in text format, of course. So we have the type. Okay. We have the version of the app protocol. We have the payload type, which is carried in the message. So as I said, one is the zip type. We have the capture ID of the node, which is sending the duplicate info. So yeah, if you have a big network, you want to know to assign an IP to each node, and we have some information about where the packet was received. We have so IP family, protocols, so UDP, etc. And the source IP and destination IP of the original message. That's how, in the Homer interface, the flow are built, basically. And you see at the end, the payload is basically the whole zip message. So in this compose that we've seen here, everything should be up. Okay, in this compose, in this compose, I've also added, Lorenzo did, a Docker container with the appgen command. So if you want to run appgen, we have two ways. One is to install Node.js 10 locally, clone the appgen repository, and do an npm install. Then once it's installed, you launch appgen specifying the configuration that you want to send, so the scenario that you want to send. Or you could do it with a Docker. We have an appgen Docker image, and you could simply run the Docker container telling to attach it to the network created by Compose. So first, I've put in the Docker Compose this container. So when we have launched the Compose, at the same time we have injected some traffic. So let's see if it works. So let's first go to the, and I have it here. Yeah. So this is the Homer UI that we just pinned. Okay, so this is
password zip capture. Password zip capture. That means zip capture.
Oh, yes. if someone ran the command, the password is zip capture. And so this is the new Homer UI. It's better, definitely better, cleaner, and the famous problem of the timestamp here solved. So this is enough a good reason to switch to Homer 7.
So we automatically update it on new request. Yeah.
Yeah.
So it's not.
Let's search in the last 10 minutes. Again, we have the search result, which are you should be used to. Okay, and then you call the call info result. You have here all the messages belonging to a call. As usual, the flow. And one important difference new about the flow is that now in the flow you see also the other messages that are sent or received. For example, we have the logs.
So it's not only SIP messages will be arrived on this tab. It's all messages what will be correlated or has been correlated to SIP. It will be also can be arrived here.
Yeah, and for example, at the end here we have the RTCP information, the RTCP report. So everything now is displayed in the same flow. Also, the QoS tab has been reworked, quite a lot. We have the logs tab that show you all the logs sent to app to the capture server via app encapsulation. But what I was saying, here we have a tab, the Loki tab. So with the Loki tab, we can search in the Loki log database. And what we can search for? We can search for, of course, for everything that Amplify has sent to, because Amplify is sending all the SIP messages and the stuff that he received also to Loki, if you enable it. But let's suppose that you already have a Loki in your system, and for example, is parsing, it's ingesting logs from CG rates.
And think about Loki like
it's a
cloud syslog, yeah, for you. So everything what you can send to Loki, it will be stored, and you can exactly.
But you can search for it.
Yeah, for any patterns.
Yeah. So for example, here. By default, we search. We search for what Amplify server has sent. So you see everything has been sent. But as I said, let's say that this Loki server is already it's not this one installed with a bundle. It's a Loki server that you have in your system, and for example, you are sending CG rates log to Loki, or whatever you want. Yeah, for example, in this scenario that I have, I'm simulating that CG rates is sending some logs to Loki, just to show you that. For example, if you have another application, you can search for. In this case, we search for the call ID of the call that we were looking for, but you could be interested in search for the user, for the callee. For the caller or the callee or whatever combination. Just think it's a text search, so you can basically search everything that you're
Especially, for example,
interested.
Kamailio can also send this information, what you have in your script scenario in config. You can also send xlog, and it also can arrive to Loki, and you can correlate this information to real call. So it's very powerful, and this Loki tab, it can also be connected to Elasticsearch. So it's not only one engine. It can be anything.
That's it.
Yeah, okay. Normally, you can also show how to make a remote search as well.
Yeah, but I don't. We don't.
In Homer, go Homer. Okay, it's about Homer interface. It's almost same. So it's same widgets. You can exactly make some configuration change. You can add additional forms, fields. It's all what you can do. So it's all automatically. Yeah. So also you can do. We have some Loki search. Yeah. We can save, and we can search for any logs. Wait a second. If we can find, last inning probably.
Yeah, last hour.
Last hours, yeah. No, could not find. Let's try again. Yeah, method equals invite, yeah? or server. Server method invite. Boom. It works, yeah? So normally you can exactly from these widgets, you can make directly search in Loki for anything, yeah? So, and it will be exactly arrive on your page. And yeah, what else? Well, probably we can do Jitsi event on the local.
Yeah,
if it's possible.
Okay, so I shut down this one. Great to see errors. So one of the latest integration that is still ongoing is integration with the Jitsi server, Jitsi media server. And I'll spin up now.
So at the end, what we should see, it's everybody can join to Jitsi conference.
I'm spinning up a server. You can connect to this 35 242 255 125 on port 8443.
With HTTPS.
Oh, yeah. Forget.
No.
Great. Oh, okay. Still.
It's downloading. Yeah.
Okay, don't know if we still have the time, but the idea was to show you how we collect in Jitsi the events, and we don't have the Homer UI because it's a different case. But how you can use Homer with Jitsi to have statistic about the conference room, how it went, if anyone had some connectivity problem or.
So normally in this case, it's Homer without UI. So we collect all statistics from Jitsi stuff, and we send this information to InfluxDB, and we can use Grafana in this case and see exactly packet loss or delay and jitter and all this information what you really need to control quality of your conference. So can you check?
Okay.
Its time is over. Okay.
I think
it's
I think the
time.
time is up. Sorry.
Okay.
Just to see if it works.
Okay.
Okay. So KV 2019. So can you join?
Someone is joining? Yeah, because otherwise we won't have too many statistics.
Otherwise, it will be exactly jitter will be perfect. No packet lost, and it will be nothing to show. So normally here it's exactly JIT. We will send this information to Homer, and it will be displayed in Grafana. Oh.
Oh, yeah.
Dangerous demo. Yeah.
Okay, so we have few points here. Well, yeah, we can see on the far right.
So if you will join, you will see exactly more dots on charts. But LTT, you see also 33, and packet lost is 1. So statistic is coming.
Yeah, okay, I see
Okay,
people. Yeah, and this was an example of how you can use Homer kind of differently of what you are used for probably. So you won't see flows and call flow because it doesn't make too much sense to graph all the events that we can have in a conference, like user joined, left, mute, unmuted. It's more interesting to have statistic about the actual quality of the conference.
Okay.
That's it for me.
Yeah. Any questions? Yeah.
Okay. Thank you. Thank you very much. So there's one question over there. Okay.
Thank you for the presentation. It was great. We just playing last couple of weeks with Homer 7, and it's insightful. The question is about CG rates and Kamailio. You showed that Homer had both logs and they were matched. How to configure CG rates part as we
CG rates, this is not about configuring CG rates. In this example, I just suppose that you have a CG rate running, and CG rates that simply they're logs. So these are those that I showed are the application logs that are being parsed by Promtail, which is the agent, the Loki agent. It's scanning for the logs that you instructed it to do.
We just get logs from the local machine where CG rates
okay, it's normally, sorry, I interrupt you. It's because Eugen exactly made Twitter this morning, and he will implement it exactly API between CG rate and Haplify server. So exactly, CG rate will send over push method to Haplify server, and he will collect all CDRs and push to Loki. So it will be automatically.
Where we can find some examples,
So tomorrow, Eugen will arrive. Yeah. So he's arriving tomorrow, and we can discuss exactly about this case.
Okay, great. Thanks.
So, but yeah, also we spoke with Dan, and Dan is absolutely happy to have these features. So all will be. Yeah. Great.
Yeah, sorry. This was really just an example of how you can leverage other logs from other application. Or let's say you are looking for a call in Homer. Instead of switching to another context, so you write.
It's great to have everything in
Yeah, but but it's not forcefully your Loki of your installation. It can be probably
Loki, yeah.
it will be a remote Loki that you have centralized for all your platform.
Sorry.
Okay, we think we have time for one more question. If there are more questions, you can also meet outside,
Yeah.
and
we
or
have calls, yeah.
maybe during the coffee break.
Yeah, hello. Question about you mentioned that you're using Docker everywhere. So how do you survive with a database in Docker, or you're using external database in production?
So in production, I'm using an image and an external disk. So managed managed in a traditional way.
So
I mean,
Docker has only application, yeah, but it's stored to.
I'm not using.
No, okay,
I'm
but
not
if you're
using it
talking
simply because they're images. So one, and it's only in a, I'm saying, insert mode, and I don't really need to have an HA on this side.
But you're providing Humor as a cloud service, so it should be reliable.
No, you can install multiple Docker images on your server. So it's no cloud, it's just another computer, yeah. So and in this case, you can exactly make clustering with Docker container. Okay, in this case, you should think about Docker just container which can include Postgres application, nothing more. So and it's installed on one server. Another server view has another Docker, but you can exactly make connection between two Docker's container and make cluster solution. And in this case, you can write to complete to cluster.
Okay, thank you, Dan.
But if you don't like Docker, you can install just